Welcome back to Newcastle Central. I've been playing around with signaling over the last couple of nights. I'd mentioned in previous videos, I got some of the Trendtech signal kits. So I have a 3-aspect signal and then a couple of the 2-aspect signals. They're fairly easy to put together, a little bit fiddly. I'll show some clips on how they go together. And then I've been working off an Arduino, trying to figure out how I could do some routing of the signals. So there's a couple of push buttons in here to say, okay, I have a train that's ready to go from platform 1 or a train going from platform 2. I've also then done a little bit with some photoresistor sensors, just to simulate, sensors that would be mounted underneath the track in between the rail ties here, so that as a train moves over, you can sense whereabouts they are. I've looked at some of the commercial things from Heathcote Electronics and companies like that, but just as a recap of what I'm thinking here, what I would like to be able to do is on this control panel be able to say, okay, I have my class 108 sitting back here on platform 12. So on platform 12, I'd like to be able to push a button that essentially then routes that train or gives the okay on that train for the signal lights to then move it out onto the southbound line. So I need lights to then turn green to let that go through. The photoresistor sensors is then automation, which is more what some of the Heathcote Electronics boards would do, so that as the train then passes those sensors, those signals trip to red, next one would trip to red, next one would trip to red until it hits the main line. Once it's on the main line at that point, then there could be some timer on the lights, or it could even go down the line. And so we'll go from green to red, yellow, back to green. So that's kind of what I'm trying to do here. Was going with these Trendtech signal kits just because they're only about £8 or £9 a piece, I think, including the printed circuit board with the LED. So the actual Trendtech signal parts themselves are relatively cheap. Arduinos you can probably pick up for £5 to £10. This is one of the somewhat knockoff Arduino boards, but they work just fine. So let's have a look and see how I put together the Trendtech signal kits and how I kind of start the step through figuring out how to make these signals change colors, how to do some of the timing, how to do push buttons, and some of the photoresistor stuff. This is the Trendtech SK4 signal kit. This is actually a 3-aspect signal kit. I've already gone ahead and made up a couple of the 2-aspect signal kits. That's the finished product, what it ends up looking like. But it comes in a blister pack like this. All the plastic pieces are on a sprue. These ones have the LEDs already fit on a little PCB, which you can look at. So these ones run at about £9 a piece, including those LEDs on the PCB. You can get the kit itself for about £4 or £5, I think, and you have to add the LEDs yourself. These don't have any of the DCC controllers built into them. You can get them pre-built already like that with a DCC control or DCC chip rather already on them, but they start from like 25 to 30 pounds. So go ahead and build up this 3-aspect one, and then that'll give me 3 that I can start to play with and figure out how they can all work together. This is all the pieces once they've then been cut off the sprue, so there are a few pieces that are left. What actually seems to happen is for each of the kits you get the 2, 3, and 4-aspect signal heads, and you can just cut off whichever ones you need. So in this case, cut off the 3-aspect heads. This is what the LEDs look like. They already come on a circuit board, and pretty cool are actually the clear, try and zoom focus in, maybe not, they're the clear LEDs, and so they don't actually come through until they're soldered on. So the instructions quite clearly show how that they will get wired up here, but essentially the top one is going to be for your resistor, for going into red. You then got common, which will run through a resistor, and they're suggesting 1000 ohm resistor, 1k ohm resistor, which will probably vary depending on what voltage you're actually putting through. And in this case, yellow and green. That bottom one is unused. They may well be using the exact same tooling and the exact same PCBs if you're also going to have the DCC chips on the bottom of them. And so we switch over to one of the 2-aspect ones that I had already put together, and look on the bottom of that one, that's going to have red, common, green, and then an unused one on the bottom too. So it just seems like a fairly common approach that they have unused. So now that we've got that together, all that happens is you'll slide this silver little piece off the actual PCB itself, slide through the top of the head mount, through the base, glue the base on, and then you can start to actually put on the signal kit. It gets a little fiddly with the ladder and these handrails and mounts and stuff like that, but it's not too bad. The main part is just getting these cleaned up off the sprues so that they're nice and smooth. Actually gluing them together is fairly easy, and again, the actual instructions, very clear as to how you put these through. So I'm going to go ahead and put this one together, get it all glued up and ready, and then we can start to solder on the leads on the bottom one and start playing around on the breadboard and testing these out. Yes, that's the 3-aspect signal now done. It turned out pretty good, so I'll sit alongside the 2-aspect ones. The real fiddly parts on these are on these rear rails, these rear kind of guard rails, to stop the man falling back once he was climbing up there. These are very, very thin pieces of plastic, so getting them off the sprue itself is hard enough, but even once you've got them off, I found out they weren't quite the width required, and it wasn't really the position of these side rails. They just weren't quite the width required, so you do have to flex them a little bit, and in doing so at least one if not two of them broke. So hopefully they're going to go and dry up okay. A little bit of extra detailing is you've got a little phone box you can attach on there, and then up on here these are just number plates. So included within the instructions are little pieces that you can cut out and put numbers on. So that's pretty much all those three drying up now. Let those finish up, solder on those, solder on some quick leads on the bottom, and then put them into a breadboard, and we can start throwing some switches, making sure that these all work, and then try and hooking them into the Arduino and see if we can get multiple ones to fire based on what particular route that you will be selecting. And the idea there is that, if I wanted to, I could try and figure out some kind of interface in a JMRI. I don't know if I would end up putting DCC chips onto the bottom of these, because again, price-wise that'll add up. These are already getting at £9 a piece. By the time you put on, even if you went with one of the multi-controller boards from Trentec, it's still going to add up to somewhere close to 15 to 20 pounds a piece. So these ones I'm going to try just controlling it almost through like an analog approach, just putting in my own kind of control board. We'll try it out. At least the signals I know I'll reuse even if I don't go with the Arduino approach, but we'll try to get those connected up and see how that works out. Okay, so this is now the signal is wired in, and if electronics is not your thing, don't worry too much about this part. Right now I should probably have shown the signal so wired up before I then showed the Arduino part. If we come in, this is what we had looked at on the instructions from Trentec. It's basically the red LED is that top point, black is then the common, yellow, and then green runs off. So that's the 3-aspect signal. We switch over to one of the 2-aspect signals. You just have red on the top, and I ran out of black, so I switched to blue. But blue is then the common, that middle one. Green is then for the green LED, and the bottom one is only used on both the 2 and the 3-aspect signals. So a little bit not fiddly, I guess, but one thing that I realized when I was soldering these on is that the idea is that you would drill a hole in the baseboard, drop the signals through, and then you would route the wires. But now that these are soldered on, there's obviously no way that you could pre-solder these. So that was kind of one snag that I realized when I went through and did this. And this, again, is all just kind of a learning experience to figure out, is this how I want to actually do the signals on the main layout itself? I'm just hanging out, working off a breadboard right now, but I did realize that it was really going to become a problem to try and drill the holes through these and then try and wire all of the cables onto these little PCBs. They got very, very small connection points, and they do also need to be at an angle as well, so you have to kind of bend the wire 90 degrees to be able to do it. So that would get a little bit fiddly trying to do that underneath the layout. It was kind of enough of a hand trying to do things like point motors. So that's one to bear in mind to think about. One thing that I could do, I'd seen some people do with point motors, is essentially build a little connection plate. And so you would solder the wires onto a little connection plate, and then a connection plate could then slip over or screw on somehow. So that's one possibility for these, because if I've got 15, 20 signals, that's a lot of laying underneath with some pretty fine soldering to try and do. So It's one thing to try and figure out. The other thing that I realized when I was going through and doing this, if we do now start to move over to the breadboard a little bit, and again, don't worry too much if electronics isn't your thing right now, but it said from the trend check instructions that each of the commons needs to run off a 1K resistor, and that's just the recommendation. I'm assuming that's if you're running like 12 or 16 volts from the mains. I'm actually only pushing 5 volts off the Arduino, so I stuck with the 1000 with the 1K resistor. But you can't piggyback these. Each of the commons, each of the negatives needs to have its own resistor. If you try and run it off one, at least I was finding that I wasn't getting all of the LEDs lighting up. So that's one thing to bear in mind. If we come over now to what the breadboard actually looks like, a little bit more complicated than it probably needs to be, and it's really because of all these push buttons that, not all of, but 2 of the push buttons that I'm using. There is a lot of wiring, additional resistors that go with that, but in essence all that I have done is hooked up red, yellow, and green from this 3-aspect signal into the Arduino, and so each of the red, yellow, and green then has one particular output pin, and then the 2-aspect signals, the same red and green, has an output pin, and then the commons pick up the ground through those resistors. So Arduino, if Arduino is somewhat new, is basically just a small little microchip that you can program. So it's fairly basic. Again, it looks kind of complicated if electronics and if programming isn't your thing, but once you figured out some of the basics, it's not that bad. So disclaimers that I have done some of this in the past. This is not my first roll with an Arduino, but really all you're doing is plugging in an LED into one of the pins. Come close. Plugging into one of the pins, digital I/O pins, and so you then tell the Arduino, I want that pin to be high for on or low to be off. And obviously if it's high, then an LED would light up. If it's low, then that LED would go off. So what are the push buttons doing? Push buttons are so that I can then decide I want to route platform 1, and again I'm assuming that the 3-aspect signal would be on my main line, so green, and then it would cycle to red, then yellow, and back to green. I'm assuming this is going to be platform 1 is a 2-aspect signal, and then this is platform 2 is another 2-aspect signal. So right now the default state when the Arduino would power up is that the main line has green to go ahead, platforms 1 and 2 are then red, and that's kind of what I would be expecting to happen in my own layout. If I can then kind of wind my way through and say, okay, I now have a train ready to depart platform 1. So platform 1 will now switch to green, and after a few seconds it will switch to red, and that's assuming that train's past a sensor. So the train's out the platform, it's now on the main line, it's past a sensor on the main line, so the main line goes red. 5 seconds it will then go to yellow, and after another 5 seconds it should now go to green. So main line's green, there's another train that would then be able to depart. So right now these are just on timers. What I would be looking at is probably some kind of photoresistor sensor that would go underneath the track. So as the train would depart out the platform, this would then cause that to go back to red rather than just my 5-second timer that I have right now. And then again on the main line, a photoresistor underneath the track, so once the train passed the signal on the main line, that would trip it. So you can do the exact same on platform 2. So let's say we now want to route out a train on platform 2. It will go to green, it's a 5-second delay, but it will then switch to red. Main line was on green the whole time because essentially what you want to do is route through and say let me go through. Now it's going to go to red, 5 seconds will go to yellow, another 5 seconds that will switch over to green. And again the platforms are now on red because no trains can depart. So if you now expanded this out across all the platforms, that would be Newcastle Central. That's essentially what you're controlling. So I just have the 2 right now. If we try platform 1 again, you can say, okay, so platform 1, it's a little weird with the way the light's going, but it is just red and green. It's just kind of the angle and reflection. So when we said, platform 1 is able to go, platform 2 then had a red light, platform 3, 4, 5, 6, they would all have red lights along the same way. Technically the mainline routing is being switched to green as well. There could be an instance, I guess, where if I wanted to put the mainline on red just to hold trains, so I couldn't allow anything to pass through. What I may want to do, let's say on the north main line, I might want to say, okay, on the south side of the station, I want to put a red light. I want to stop any trains that would just be passing through, like a freight train, for example, because I have a train on platform 1 that I want to depart. And so as part of switching the platform lights to green, it is technically also putting this on green. Now, there isn't any logic in this. Try and switch over so you can see some of the code. There really isn't any kind of logic in this right now, but this is essentially what's controlling those lights going on or off. Route platform 1, route platform 2, and so at the top, if we come in and look again, don't worry too much about the programming side of things, but these are just corresponding to the pins that we looked at on the Arduino. So main line red, main line yellow, main line green, 13, 12, and 11. And if we spin over those first 3 that we look at, so we've got ground, black, but then we've got 13, 12, 11, red, yellow, green. They correspond over to red, yellow, and green on that 3-aspect signal. So that's all that we're defining there. Do the same for red platform, green platform. There's my 5,000, so it's in milliseconds, so 5-second delay. And then our push buttons 1 and 2, and again, there's not a lot of logic. Say that we want all of these pins to be outputs because we want to output something to those LEDs. We want to output either, send power or don't send power. And then the buttons we want to define as inputs. And again, this is all, it'll get a lot more complicated this, I'm sure, as I add things out. But, this is to show that the Arduino isn't that complicated once you wrap around. Okay, it's LEDs, high and low. We've got delays. And then we had those push buttons as well. So if push button is high, if we push the button, then go off and route those. Otherwise, it will roll back. Here's our initial definition, what we want to do when we start it up. Set the main line green to high, and the platforms should then all be low. Other than the red lines, they go red lights, they're high. So there's somewhat electronics, somewhat programming go into this, but this is functionally, what I was setting out to achieve. I think the next step is probably going to be try and add in those photoresistors so that I could pretend, okay, I'll put my finger over the resistor that now is the train that we're passing over, and try and get these lights to now work on photoresistors rather than just on a delay. There is this, again, electronic side. There's different types of Arduino boards you can get. This is what's called the Arduino Uno. It's actually somewhat of a knockoff board because it's a heck of a lot cheaper. It's about 1/5 of the cost. This is then the Mega, Arduino Mega, and again, it's a knockoff board. Couldn't actually get this to work straight out the box. I need to do some tinkering with that one. I guess it's one of those again where you get what you paid for, but essentially the reason why I want to use the Mega is the sheer number of pins that we have here. So I've got a 3-aspect and then 2 2-aspect signals, and I don't have a whole lot of pins left on that Arduino Uno. I do kind of run out of pins fairly quickly. I can't remember the total number of pins that you can use, because you can switch some of them to work with LEDs. The Uno just has a lot more. Because I'm going to have a lot of signals, I would need more like the Uno boards. I also need to figure out how can I link Uno boards together so that I can have them talk across backwards and forwards. So that would be a little bit more complicated. I don't know if the Uno can do that, but again, this is just kind of a proof of concept to see, does this work? So I think the next part is going to be do the photoresistors, see if I can get that working. That at least gets me along the right lines of, is this the approach that I want to be taking here, at least for now, with the way the push button would work, so I could route trains out from that main control panel. This is what I was wanting to achieve. So try photoresistors next, and we'll come and check and see if it works a little bit more prototypical for trains getting dispatched and automatically changing signals. Okay, so I've made a little bit more progress here. There's even more electronics that are showing up. This is starting to get a lot more complicated than I was expecting. Mainly because of the number of resistors that are required in order to do things like push buttons, and I'm now using photoresistors. So if we try and move over, and here we have 2 different photoresistors that would be simulating a sensor that would sit in between the rail ties next to the signals. So let's assume that this one right here is going to be the signal for platform 1, and we're going to assume this is platform 1. Right now, platform light 2 is connected, but it functionally isn't doing anything. So this is platform 1, this is our main line. So the 2 aspect signal on platform 1, 3 aspect signal on our main line. So come back over here, we'll assume that this is the photoresistor sensor on platform 1, and this kind of hiding out underneath the other wires is the photoresistor sensor for the main line. Each of these then has a 10,000 ohm resistor that's bridged across. You then get power into the top leg. You've got negative that comes into the bottom through the 10,000 ohm resistor, and then you actually take your pin over as an analog pin in the Arduino. And this is why I'm probably already starting to lose people. You know, that again, I thought that this was going to be a little bit easy. Didn't realize how much was going to be involved in this. So if you know a little bit about electronics and Arduino, it's not that bad, but I can already see that this is probably starting to stretch things beyond what a lot of people are going to be comfortable in doing. Certainly when things start to go wrong, like I can put this together, but in terms of then troubleshooting when things would go wrong, and I'm only doing 2 signals here technically, so there's a little bit of additional wiring for you know, this third signal and for a button to control another one, but we've already got a lot of wiring here just with essentially, you know, 2 platforms wired up and only 1 sensor even. So as I would expand this out to what, there's 12 platforms at Newcastle Central, at least 6 of which I guess could route for north or south platforms. Plus then, you know, 2 or 3 main lines to the north and south that potentially could be routing in either direction. This becomes a lot of signals, and it becomes a lot of wiring as well. So we'll see how it goes, but at least for now, I do have this working. So if we kind of reach in and trigger the button, what we should see is I've now routed off platform 1. So the light here for platform 1 has gone to green. And we got our photoresistor sensor. So if we assume that our train is coming over, it's now past the sensor, and so now the signal on platform 1 has gone red. Our train is now moving out through the platform, nothing else is allowed to enter that block. As it would then move on to the main line, it would then come over that photoresistor sensor. If I can get my finger in the right place, that then goes to red. Now it's on a timer. I have it set fairly short, only at 5 seconds, just that I'm not here waiting for a whole bunch of time. We'll probably expand that out to, you know, 10, 15, 20 seconds in reality. So again, if we just try and do that all at one while I can actually see where my finger's at. So there's now train coming through platform 1. As it would cross over that first light signal, now I can't send anything else out. My train's now moving on to the main line, and then when I cross over main line, that goes to red and we'll go back through the cycle. So that's functionally how it would work. Again, I'm still, you know, a little unsure as to how I could scale this up. I can definitely see the execution of this. I'm not sure if there are easier ways of doing this. I mean, there are, but in terms of cost, I guess, the other option that I've been looking at again is, okay, what if I actually put a DCC chip onto each of those and then control that just via a DCC controller. Then I'm going to do it manually, which is an option. Can hook into Heathcote Electronics, do a bunch of different boards that can control these. The problem with the Heathcote Electronic boards is that although they've got the sensors integrated into them, it can't do the routing like I want. So nothing will happen if I do 2 at the moment. But again, what I want to be able to do is have these lights ready on the platform and say, okay, I have a DMU wanting to go out from platform 1. I can set that off. Now I'm onto the automation kind of things like the Heathcote electronic boards would have. But that dispatching, essentially, I haven't found any off-the-shelf equipment that's able to do that. So I have been thinking a little bit more about how you will be able to do this. I had mentioned, I think in the previous clip, that you know, once these are soldered on, then, you know, it becomes a little bit hard to get through. Actually, it wouldn't be, because you know, you can fold them down a little bit. So you would drill a hole that's, you know, still smaller than the best of that, but you could pre-wire these up. rather than having to solder them under the layout which I had originally thought. So the more I think about this, the more it is feasible, but this becomes very complicated. And so what I might need to end up doing is figuring out, okay, how many of these am I going to need? So how many signals am I going to be controlling? How many push buttons am I going to be controlling? And design up my own printed circuit board, solder all of the components onto that, and then all of these wires would then just get soldered onto that custom printed circuit board. That's really the only way to do it. This is just becoming an unmanageable mess, and it is on a breadboard, but there's still a lot going on here. So this is kind of just a proof of concept. I'm probably just going to call it done for now. What I would ultimately want to test, which I don't really think I'm going to go to a stage now, but we'll see if there's another clip. Then I did. What I would really want to do is now get a piece of scrap wood, put some track down on it, and then put the photoresistor beneath, just to make sure that I can time it. But really that's getting a little bit more advanced in terms of, okay, what is the light reading before this would trigger, and then what kind of a delay do I need? Now I think it does it within about 1/10 of a second. Is that realistic, or would it be more like, 1/4 of a second or half a second after the train passes the signal before it would then flip to red? It's not normally an immediate, but again, I think they're more nitpicky, specific things if I was to go ahead and do this. So at least for a proof of concept, this works. It is cool to have some signals going, and seeing how I could start to do some dispatching here and routing of the trains. But do let me know what you think. Are there other solutions that you've seen? What have you done on your layout? Do you know if there's anything kind of built in that can do this? I do run JMRI, so I have NC power cab, but it then hooks into a Raspberry Pi that's running JMRI. So I could do something with JMRI, but again, most of what I've seen is requiring different interfaces, or essentially DCC chips on to these, and so you do the routing through there, but all it's doing is really then sending a signal over DCC. And again, the sheer number of what I would be needing here, that would really start to add up in terms of cost. So this is one way of doing it. This is probably what I'm leaning towards right now, if I could knock up a printed circuit board. But let me know what you think. Let me know the ideas that you've had. What other solutions are that are available? Has this been worthwhile? Can you see things that I could maybe do a little bit different if I do progress down this route? So thanks for watching. We'll probably be back soon with a little bit more advanced way of doing this, if I'm continuing with it, or if I've gone for something totally different. But do subscribe and follow along, because I think all this signaling stuff is going to get pretty cool over time. Take care. Bye-bye.